In the reaction sequence, glycerol is treated with potassium bisulfate, you will get X. X is treated with zinc amalgam and concentrated HCl, you are getting Y. Y treated with NBS will get Z. They are asking us to find out what is Z in the sequence of reaction. When glycerol is treated with potassium bisulfate. When glycerol is treated with potassium bisulfate, what happens? Potassium bisulfate, concentrated H2SO4, P2O5 are all dehydrating agents. When glycerol is treated with dehydrating agent, it loses 2 moles of water. So what will I get? How it loses 2 moles of water? OH from this carbon atom, H from this carbon atom. So I will get CH2 double bond C. Again OH from this carbon atom, H from this carbon atom. So what will I get? Again double bond CH OH I will get. This is enol. This is enol. Enol undergoes tautomerization. So what will I get? CH2 double bond CH double bond O. This compound undergoes tautomerization to form a compound called acrolein. Now this acrolein is treated with zinc amalgam and concentrated HCl. So zinc amalgam and concentrated HCl is Clemenson's reduction. When aldehydes and ketones are treated with zinc amalgam and concentrated HCl or hydrazine and sodium hydroxide, C double bond O will be reduced to CH2. That is the shortcut there. So here C double bond O should be reduced to CH2. So what will I get here? CH2 double bond CH and CH3 here. Now it is treated with N-bromosuccinamide. If in presence of N-bromosuccinamide, allylic substitution takes place. In presence of N-bromosuccinamide, allylic substitution takes place. This is allylic carbon. So substitution of bromine takes place on that carbon atom. So CH2 double bond CH, CH2 Br. This is, what is the name of this compound? 3-bromopropene. The final product obtained here is 3-bromopropene. So your answer is D here, 3-bromopropene. Z is 3-bromopropene.